Hey AP Stats, here we are. We're doing lesson 14.2 today. I hope you guys are doing well. Just letting you know that I am praying for you every day, and God is going to get us through this. He is good. He is amazing. All right, so just focus on today. Know that He has a plan and a purpose. Love you guys. Miss you guys so much. All right, let's do some stats. Here we go. So here's our last chi-squared test, and we're doing a chi-squared test of association or independence. So it's kind of like some books will just say it's the chi-squared test of independence, and this book says association/independence. So it's kind of both to know. It's kind of good to know both. So I'm going to try and speak up a little bit. I hope I'm not too loud. My iPad wasn't working the last one, so I'm hoping this works a little bit better. Okay, so a little review. What does it mean if two variables have an association? Well, specific values of one variable tend to occur in common with specific values of another. So what does it mean if two variables are independent? Knowing information about one variable doesn't give you any more information regarding the other variable. So you either have an association or you're independent. So how is today's test of association independence different than the test for homogeneity? Well, it's all about the way that the data is gathered. So if there is one sample and two variables, we are testing for an association. All we are doing with association independence is categorizing a single sample in two different ways. Now, if there are two or more samples, 2 or more samples or groups, and one variable, we are testing for homogeneity. Okay, they sound kind of the same. And I think these are the easiest ones to get mixed up because the first chi-squared for GOF, that one was easy because, or not easy, but easy to recognize because it only has, it's one variable and one sample. One variable, one sample. Okay, like I think of the plain M&Ms that we did. And the chi-squared test for homogeneity, we have two samples, one variable. But the test for association independence is going to be, it's kind of like this. It's like you have one person that you're surveying, and you ask them two questions. Okay, whether they are a male or female, for example, and whether they prefer English class or math class. And we did this at the beginning of the year to see if there's an association between the two when we did the taco tongue and evil eye. But now we're going to have a test for it. Very exciting. Okay, so how do you state the hypotheses for a test of association independence? Well, there's a couple different ways. So for the null, we say there is no association. Kind of like that better than the other way, which I'm going to teach you in a minute. There's no association between the two categorical variables. Or you can say the two categorical variables are independent. They are not related in the population. I kind of like no association better than the second way, so I don't know if we're going to stick with that. We might. All right, and then the alternative is that there is an association. Yeah, my writing is so bad on here, I'm sorry. Between the two categorical variables in the population, or the two categorical variables are not independent. Okay, that means they are related somehow. Okay, so what are the conditions for a test of association independence? Well, guess what? They're exactly the same for all three chi-square tests, which is so nice. And also, you get real sick of it, don't you? All right, SRS, the one sample, okay, don't say samples, it's a one sample, was random. So I picked one person in the class and we figured out if they like, math and if they're male or female. So it's one sample answering those two questions. Don't forget about independence. So the individual observations are independent of one another. You also still need to check n is greater than or equal to 10n. And then finally, large sample size. All what counts? Yes, expected counts. You got it right. All expected counts are at least 5. I feel like I'm teaching, like when I used to watch Mickey Mouse Clubhouse and Mickey Mouse would ask a question on the TV. Hey kids, what kind of a shape is this? And then I'd shout, triangle. But Mickey Mouse, and then he's like, that's right. I feel like that we're doing this right now, but it's kind of fun too. Okay. So how do you calculate expected counts for a test of association or independence? It's going to be the same way. It's the row total as the homogeneity ones. Row total times column total. Ooh, I'm going to go off the page there. Oh, that's cool. Over the table total, or total, if you want to say that. So it's the exact same thing, nothing new to learn there. Remember not to round to whole numbers, okay? Use at least one decimal when you're doing your expected counts. And the degrees of freedom are the same also as the homogeneity, so it's row minus 1 times column minus 1. All right, so let's go to the next page. And we're going to do an example from chapter 6, long time ago. We investigated the relationships between gender and having allergies for a random sample of 40 students who completed a census at school survey. Here is a two-way table that summarized the data. All right, in chapter 6, we concluded that the events female and allergies were not independent for the members of the sample. So calculate appropriate conditional distributions to verify that this is true. Draw a graph to compare the conditional distributions. All right, so this kind of takes us back to what we did in chapter 6. So we need to find the percentage or calculate the distributions and draw like a bar graph. Okay, we haven't done this in a while. So female with allergies, if you take the number of female with allergies, we get 0.435. You might want to get your calculator out. All right, and then the females with no allergies would be 13. I didn't write it up here, I'm sorry. This was, how I got that was 10 out of 23, because it was the allergies out of the total females. So female with no allergies would be 13 out of 23, which is 0.565. All right, as far as the males go, the ones with allergies, 8 out of 17 total for the males. So that was 0.471, and the males with no allergy was 0.539. So they want us to draw a graph to compare the conditional distributions. So we'll go ahead and draw a graph. Don't forget title, label, tick, tick, tick. So we could call this thing allergies. And let's go ahead and 1, 2, 3, 4, 5, 6. So that's 0.6, 0.1's here. So the females with allergies is 0.43, 1, 2, 3, 4, right about here. And we can compare that to the males with allergies. So we're comparing females and males with allergies. We can put 0.47, it's a little bit higher. And then don't forget to color it in and make a key. Female, male. All right, over here, female with no allergies is 0.56. Okay, and then this is allergies, and this is no allergies down below. And then the males were just a teeny bit smaller, and color that in. Okay, so there's a bar graph to just describe it. That's really not what this chapter is about, but sometimes they ask you to do both, so it's nice to have a little review. All right, now part B, we're going to do a test. So here we go. State. We want to test the following. We want to test the following at the alpha equals 0.05 level. Okay, feel free to you can pause the video if I'm writing too fast, but I feel like people really want to kind of get through this because I know you guys have a lot going on. You have a lot to do. All right, so the alternative is that there is no association. No association. Sorry, this is so messy. Between gender and allergies. There's a lot of other ways you can write that, but the null is always no association between whatever we're testing for here. The alternative is that there is an association. I would write just, an association, just ... between gender and allergies. All right, so here's our plan. We need to see if the conditions work. So we have a simple random sample. Yes, there's 40 random people surveyed. Okay. We have independence. So one person's allergies does not affect another. One person's allergies doesn't affect another. Okay, we can also say that male and female are, they're independent of each other also. And then we need to, now little n here is 40. Okay, since it's one sample, all you have to do is say that we need to assume n greater than or equal to 10 times 40, or n is greater than or equal to 400 that could have taken the survey. Okay? And then for the large sample size, you need to find the expected counts. The expected counts. So we have allergy and no allergy, and we have female and male. We're going to make a table. And the expected counts, remember, we're going to do the row times the column. So let's go ahead and do this one right here. So it's female 18 times 23 divided by 40. Okay? So 18 times 23. Let's see. All right, divided by 40. 18 times 23 divided by 40. We get 10.35. So that's our first one, 10.35. Okay? And then I went ahead and found the rest of them, 7.65, 12.65, and 9.35. And we can say that all expected counts are greater than or equal to 5. Okay. So, since all conditions have been met, we will do a chi-squared test for association. You could say independence test, but make sure that you say one of them at least, association or independence. Okay, so here's the do. Sorry if you didn't get that. Here's the do. So we're going to go chi-squared, and it's going to be exactly the same one. O minus E squared over E. Go ahead and put in the first one, 10, the observed minus the expected, squared over the expected, plus ... 9, the last one, minus 9.35 squared over 9.35. Okay, I've run out of room, of course, like I always do. So I write like a Shrek, Wreck-It Ralph hands. All right, so we get a total of 0.0506, and our degrees of freedom is 1. Okay, now the way that I found that is, there's only 4 of them. You could just add them up real quickly. It might even take you less time. then putting the observed into a matrix. Okay, but you can, and that's okay. And then we would get a, no, that's not the, yeah, it is. 0.05, okay, so 0.0506, that's like really close to 0. So we're looking at this area. Okay, do you think something landing in there has a high probability? Yeah, it does. What is the p-value? Well, your calculator will do that for you, or you can do that's not a chi-square. You could do chi-squared CDF, your chi-squared value, 10 to the 99, and your degrees of freedom is 1. And you get a really big p-value, 0.8220. Okay, that's big. So the p is not low this time, so what can we conclude? Here's our conclusion. Since p is greater than alpha, 0.8220 is greater than 0.05, we fail to reject the null. Okay, that there is no association. Don't forget context. There is no association between gender and allergies, or allergies and gender. Okay, keep going. And we cannot conclude, the alternative. You always forget, go back to your alternative. Where is it? That there is, I just erased that with the white marker. Conclude that there is an association between those two things. Okay? All right. At the end of the test, you can think about the scope of inference. If the results are statistically significant, you can only make conclusions about the population from the sample it was from. We can only say cause and effect with a well-planned randomized experiment. All right, so just good reminders there. Okay, so now we know how to do all three of them. Here is a good reminder of what they all look like. So goodness of fit, one variable, one sample or population. Homogeneity of populations, one variable, multiple samples. And then two variables, one sample. So here we go. An article in the Arizona Daily Star included the following table. So here's the age in groups here, and use online social networks. And then here's the numbers, and do not use online social networks. Okay. Suppose that you decide to analyze these data using a chi-square test. However, without any additional information about how the data were collected, it isn't possible to know which test is appropriate. So explain how you know that the goodness of fit test is not appropriate for analyzing. All right, well, a goodness of fit test is a one-way table. Okay, so obviously this is a matrix, okay? A goodness of fit needs to have one row or one column. This one has more than that, so you cannot say it's a goodness of fit. All right, B, describe how these data could have been collected for the homogeneity. Well, for homogeneity, you would have to have separate samples of people, from each age group and ask them their media use. Okay, so separate samples of people from each age group. Now, describe how it could have been an association or independence is appropriate. Well, that would be that you would take one sample and ask them two questions. What is their age and what is their online use? I know they kind of sound the same here. Okay, that's really easy to get them mixed up, but we're going to do a couple more examples that I've added to this packet just to help us get through the difference between them. Okay? All right, so here we go. For each of the following situations, decide what type of chi-square test is appropriate and explain why. All right, so the first one, shopping at secondhand stores is becoming more popular and has even attracted the attention of business schools. A study of customers' attitudes towards secondhand stores interviewed separate random samples of shoppers at two secondhand stores of the same chain in different cities. Sorry, I was looking at something else. The two-way table shows the breakdown of respondents by gender. All right, so this right here is interviewed separate random samples. That's the biggest thing to look for. This is a chi-square test of, think about it, what do you think it is? Yes, homogeneity. Okay, separate samples. Think about M&Ms. That's a really good way to think about this. There were two separate samples with one variable, which was gender. All right, let's see what the next one is. Here we go. The General Social Survey asked a random sample of adults, their opinion about whether astrology is very scientific, sort of, or not at all. Here's a two-way table. So goodness of fit has now definitely not it. Okay? But a random sample, one sample, but two variables. Okay? And so this has to be a chi-squared test for independence or association, however you want to say it is. Okay? The two variables are their degree and their opinion. And that's the two variables. And this is pretty easy to see. Look at, there's not more than one. So casinos are required to verify their games operate as advertised. American roulette wheels have 38 slots, so on and so on. In one casino, managers record data from a random sample of 200 spins, and this would be a chi-squared GOF, which feels like years ago that we did it, because this is one sample and one variable. All right, and then the rest of it just has to do with computer outputs, if you're able to read them, okay? When you look at this right here, it gives you all the information that you need. Here are the chi-squared components. This right here is your chi-squared value. They tell you the degrees of freedom. The p-value ended up being 0. For this right here, it has a bunch of stuff, but then they tell you what it means. Here's the count. Here's the row percent. Here's the column percent and total and all that stuff. And they also give you a chi-squared value, and here's your p-value. Okay, so computer outputs are going to output things like that. All right, thanks for listening. I love you guys, and I'll talk to you soon. Bye.